Qualitative analysis means figuring out what a substance is, but not measuring how much of it you've got. If you're measuring how much of it, that's quantitative analysis. And qualitative analysis is very important, both in real life and in A-level. And it has both an organic chemical dimension, working out, for example, what the functional groups are in a compound, but also an inorganic dimension. And you remember you've learnt tests for specific ions. So what we'll do is just remind you of those tests that you know, and also talk about the best way to describe how you would do a qualitative analysis. Okay, so here's a simple example of a sort of question you might get. So you might be told you've got a sodium compound and you've got to describe what tests you could do to try and figure out what the anion, the negative ion, is. And always in these questions it will specify test tube reactions. In other words, you can't do anything fancy. Nothing involving complicated things like measuring melting points or boiling points or doing spectroscopy or anything like that. In these questions they're looking for simple test tube reactions, and that means you need a reaction that produces an observable result. Okay, it's no point just saying, does it react with reagent X? Because if it reacts but you can't see anything actually changing, that's no good. You've got to have something that produces a colour change or fizzing or a precipitate or something like that you can see. Okay, so for this kind of question there is a specific sequence of tests, and you have to learn not just the tests but the sequence that you apply them in. Fortunately, you don't have to know an exhaustive list for all the anions under the sun. Obviously that would be unreasonable, so there is just a defined list of ones that you need to be able to test for at A-level. So the first test is that you add a dilute acid. So nitric acid is the one that's normally preferred, because nitrate ions are very unreactive in most of these tests, so adding them in like this doesn't interfere with anything. So you add aqueous nitric acid to your solution, and there are then two possible outcomes. Either it fizzes or it doesn't. And the way I think is the simplest way to therefore present your scheme is in the form of a flow diagram. So you can either say that when you add the nitric acid you get fizzing or no reaction. Now if it's fizzing, that means that your compound is a carbonate. So in this case, because we know it's a sodium compound, we would know that we had sodium carbonate, Na2CO3 was the identity, and that would be it. We wouldn't need to do any more tests. But if there's no reaction, we go on and we say, well, it's not a carbonate, so we do the next test. And the next test is that we add barium nitrate solution. And the reason we do that is that it will detect sulfates, because you will get a precipitate of barium sulfate. So again, two possible outcomes. You either get a white precipitate or no reaction. And if it's a white precipitate, that tells you that it's a sulfate. So in other words, our compound in this case would be sodium sulfate. Now it's crucial that you did the tests in that order, because if you'd started out with the barium nitrate test and you'd had a carbonate, you'd have got a white precipitate of barium carbonate. So you would have wrongly thought that your compound was a sulfate. So you have to eliminate the carbonate from your inquiries first before you can do the sulfate test, and that's why you've got to learn the sequence so that you don't get those false positives. So if there's no reaction, you go on and you do the next test, which is to add silver nitrate. Which you have to learn is AgNO3. And this time there are four possible outcomes, because you can get precipitates if you have halide ions and they are different colours depending on which halide you've got. So you might get a white precipitate, which means that you had chloride ions present, so NaCl would have been the compound. You might get a cream precipitate, which means Br minus, bromide, so we'd have had NaBr. Or you might get a yellow precipitate, which is the iodide one. And if you get no reaction, it means that it's not any of these. So it's none of these anions. So I think that a flow diagram like that is a very nice, clear way to show what you do, what the logic is, and to make it very easy for people to follow. If you hate them, you don't have to do it that way, but you do have to make it clear not just what the tests are, but what the observations are, and what the implications of those are, and especially the sequence that you do them in. And you can adapt that to, there are various kinds of questions you get that, here are 5 compounds, but you don't know which one is which kind of questions. And again, you can adapt that kind of scheme to those sort of investigations quite easily. Now here's an organic example. So you don't know very many organic test tube reactions yet. You will learn some more next year, in which case these questions require a bit more thought. But you do know a few, so again, maybe before you watch the rest of this, just have a look at these 4 compounds and say, suppose you've got a sample of each of them, but you don't know which one is which. See if you can think of a sequence of tests which would tell you which one was which. And just give the flow diagram approach a go. See if you can represent your answer in a flow diagram. Well, there are lots of places we could start, but one obvious one would be to remember that if you have an unsaturated compound, like this one, all the rest of them are saturated, this will decolorize aqueous bromine in the dark, whereas saturated compounds will only react with bromine in the presence of UV light. So that's very easy to pick out this one because it's the only one that will do that. So we can write that on our flow diagram. Add aqueous bromine to all the substances in the dark. In the dark just means without UV light. It doesn't mean you actually have to do it in complete darkness. And there are 2 possible outcomes. Okay, if the bromine decolorizes, that means that it's an alkene, and therefore that means that we've got this one. If there's no reaction, it's one of the other ones. And the point about this kind of question is, once you've identified that compound, you don't test it anymore. So you don't have to worry about, but what's going to happen with that compound when I do my next reaction, because you won't do it. Once you've identified it, that's it, it's out of the picture. And you now just test the remaining substances. So you make that clear when you continue that. So you're going to do your next test just on the remaining substances. So you look at these, and one thing you might notice is that this one is a primary alcohol. This one is a tertiary alcohol, and that should make you think about oxidation, because remember that primary alcohols and secondary ones, but we haven't got one of those. So primary alcohols can be oxidized by aqueous acidic potassium dichromate, and when that happens you get a colour change. Tertiary alcohols can't. Tertiary alcohols can't be oxidized by aqueous acidic dichromate. So that will distinguish those 2. This one, you might think, well, I don't know what bromoalkanes do with aqueous acidic potassium dichromate, but the rule you stick to is if you don't know the reaction, you assume there isn't one. in real life that can be a complication you might have to worry about, but in A-level you can really stick to that rule. If you haven't learnt that there's a reaction of aqueous acidic dichromate with a bromoalkane, that's because there isn't. So that means that's going to be a good test, because this one's going to react and these two are not, so we'll have narrowed it down some more. Okay, so let's say that then. We'll add aqueous acidic potassium dichromate and heat. If you're not doing it in a flow diagram, you have to make it clear that you're just doing this to the remaining substances, but that follows, without you having to say it explicitly from the flow diagram structure. So again, two possible outcomes. If the solution changes from orange to green, you need to learn these colours. That means that it's a primary, or it could be secondary alcohol, but we haven't got a secondary one here, so we'll say that's a primary alcohol, which is this one. So that would be that one identified. If there's no reaction, then we're down to the other two. So we've got these two now. So what can we do? Well, you don't actually know any reactions of tertiary alcohols yet, at least we haven't come across them in the course, but you do know a reaction of the haloalkane, because remember that if you heat it up with aqueous silver nitrate, you get a substitution reaction where the bromine is replaced with OH and you get Br- ions released into the solution. And of course, because you've got silver nitrate mixed up with it, you're going to get a precipitate of silver bromide, just like we were talking about just a few minutes ago in the qualitative tests for halide ions. So that would be a good thing to do. So what you do for those ones then is you add aqueous silver nitrate. It's very important to specify aqueous. Okay, same here, same there, because it matters. If you just add solid silver nitrate, that's no good. You're not going to get the right result, and you can't think, oh yeah, they'd know what I meant. Yeah, of course they do, but that doesn't mean they're going to give you a mark for it. You have to say it. You have to say it right. So you add aqueous silver nitrate and warm. And again, two possible outcomes. That one, you don't know any reaction of alcohols with silver nitrate. There isn't one, so that would be no reaction. And the one with no reaction is that one. Okay, in this case it's your tertiary alcohol. If it does react, then what are you going to see? Well, the bromide ions released when this reacts with the water, those bromide ions will precipitate out with the silver nitrate to produce a cream precipitate of silver bromide. So you get a cream precipitate, which means that you have that compound. Okay, so again, what you need to do is learn those tests. Those really are the ones that are the reactions you've learnt so far which have a visible outcome. You know a lot of other organic reactions, but you can't see that they've happened. So those are the important ones when it comes to qualitative analysis. And practice setting out your answers clearly like that.